consecutive elements after rearranging the array. The array is considered circular, meaning the last element is adjacent to the first. Approach 1. Sorting the array. Sort the array in ascending order. This brings the smallest elements to the beginning and the largest elements to the end. 2. Pairing largest and smallest. Pair the smallest element with the largest element, the second smallest with the second largest, and so on. This pairing maximizes the absolute difference between consecutive elements. 3. Calculating the sum. For each pair, calculate the absolute difference. Since the array is circular, each pair contributes to the sum twice. Therefore, multiply the absolute difference by 2 and add it to the total sum. Time complexity. Sorting the array takes n log n time, where n is the number of elements in the array. The subsequent pairing and summation operations take linear time, n. Overall time complexity, n log n. Space complexity. The sorting algorithm might use extra space for sorting, typically log n, for efficient sorting algorithms like merge sort or quicksort. The additional space required for variables and calculations is constant, 1. Overall space complexity, log n. Why this approach works? Maximizing differences. By pairing the smallest and largest elements, we ensure that the absolute difference between consecutive elements is maximized. Circular array. The circular nature of the array means that each pair contributes twice to the sum, further increasing the total. Optimal solution. This approach guarantees the optimal solution by systematically maximizing the differences and considering the circular property of the array.